Hello, in this part 2 of Module 10 video, we're going to look at partial fraction decomposition. Okay, so what is that? So we studied earlier in this section a ratio of polynomial function, which is called rational functions, right? So these are functions, but now we're going to look at rational expressions. So these are not necessarily functions, but we're looking at more techniques to combine and decompose rational expressions. Okay, so rational expression is a form of nx over dx, so polynomial over polynomial, but they're not necessarily functions. So like these. Okay, they're just expressions. So how do we combine rational expression or just fractions, two fractions in general when we add? Okay. We need to have a common denominator, right? So if I want to add these two, here I have to multiply x plus 3 over x plus 3. Where on the other side, I have to multiply x plus 1 over x plus 1. So then when we do this, and then we have a common denominator. We have x plus 1 times x plus 3 as a common denominator. So I'm only going to write it once in the denominator. Then top part we have 2 times x plus 3 plus 5 times x plus 1. Yeah, so we can simplify this. Equal the bottom, we can write it as x squared plus 2 with 4x. So add 4x plus 3. In the numerator, we have 2x plus 6 plus 5x plus 1. Then we can simplify to collect like terms. 7x plus, oops, this is 5, sorry. 11 over x squared plus 4x plus 3. So what we just did was we combined this, we add this to a rational expression into one fraction expression. So today we're going to learn how to start with the combined form and end with this. And this procedure is called partial fraction decomposition. Okay? So we just combined two fractions to one. We're going to learn how to decompose one fraction to two different parts. Okay. So there are many cases, but in this class we're going to look only two main cases. So first, we always have to factor the denominator if we can. And one of the following cases will result. Again, this is just two cases we're looking in this class. There are a lot more cases. So first case is we have distinct non-repeated linear factors. So we have, for example, 2x plus 3 and x minus 1. And each of these are linear expression, right? And they're not repeated. So this after we factor, we have non-repeated two parentheses like this. And the left side and right side are different. Case 2 is we have one or more repeated linear factors. So let's say we factored in, but we have x plus 1 to square times x minus 2x minus 4. So this means this is the same thing as our factor is actually x plus 1, 2x minus 4. So we have repeated linear factor in the denominator. So we're looking only two main cases, although there are way more cases exist, but they're beyond scope of this course. So let's look at case by case. So case 1, dx has only non-repeated linear factor. So first, always factor the denominator. Again, these are just me demonstrating. So you need to be comfortable with this step, right? You need to be able to do this without these steps given. So, but this is since first time you're seeing it in this class, we're going step by step. So first, I have 5x plus 13 on the numerator. Denominator, I'm going to factor this. So I'm going to factor as x plus 5, x minus 1. Okay, so we factor so that we have two different linear factor. Okay. Then we're going to express as sum of partial fractions. What does that mean? So we'll copy down the top part with factor denominator. Then here, what we're going to do is we're going to write a capital A over x plus 5 plus b over x minus 1, because this is a common denominator, right? So let's separate them. And now we're trying to find what a is and what b is in terms of expression. Okay. So again, order doesn't really matter. I could have written x minus 1 here first, x plus 5 here first. That doesn't matter. Okay. As long as you do the calculations correct, we'll get the same answer. Now we're going to multiply both sides of the equation by least common denominator. Okay, so let me just copy down the top part first. I'm going to give some space. Plus b x minus 1. So what is the least common denominator? It's this. So I'm going to multiply this both sides to every term. I'm going to multiply here, then I'm going to multiply here, the parenthesis like this. But when we do this now, this we need to distribute. So multiply here and multiply here. Okay. So we're going to distribute this and write in the bottom what will cancel out. So let's go right here. So this, I'm going to write here this part. Since x plus 5 cancels out, x minus 1, x minus 1 cancels out, we have 5x plus 13 on the left side of the equal sign. Equals, now let's look at here. We're going to multiply this to the first term first, then x plus 5 and x plus 5 cancels out, right? So what I have left with is just capital A times x minus 1. And let's look at the other side. Now I'm going to multiply this to this expression right here. Then x minus 1 and x minus 1 cancels out. So what we have left with just b times x plus 5. Now it says distribute and regroup. That means distribute a. So let's do that, and b to each equation. So I have 5x plus 15, ax minus a plus bx plus 5b. Okay, so let me bring this expression right here. Okay, so we're going to regroup. That means whatever with the x terms, I'm going to write it next to each other and others on the other side. So again, the left side wouldn't touch. We just leave it as it is. Right side, what I'm going to do is I'm going to do ax plus bx minus a plus 5b. So what does this tell us? We know that ax plus bx should give us 5x. Right? So collect like terms, ax plus bx should give us 5x. That tells us, let me write in step 5. That tells us that a plus b must give us 5. Then 15, let's look at 15. Negative a plus 5b should give us 15. So negative a plus 5b should give us 15. So we have two equations. So using systems of linear equation solving method, we can solve for a and b. So we can use either a matrix, which it will be just 1, 1, 5, negative 1, 5, 15. We can use matrix to solve it, or we can also just do systems of linear equation. And you can choose at this point. Okay, so this one actually happens to be a little simpler with regular elimination, because we can just add, because we'll let it have a and minus a. So if you add, I get 6b. Right? Oh man, This was 13, right? My iPad pencil writing is, I'm just not getting used to it. Okay, so it's 13. 13. Okay. So this actually should give us 13, right? My bad. So I wrote 13 here, but I misread my writing. Okay, so then we have 18, right? So then we divide by 3 both sides. B is 3. If B is 3, then A must be 2, right? A is 2, because A plus B gives us 5. So we need to express our final answer in partial fraction. Okay. So what we figured out is that 5x plus 13 over x squared plus 4x minus 5 equals, what we had was x plus 5 plus x minus 1, and we got A to be 2 and B was 3. So this is the solution. But I mean, the solution is this, right? Because we just decompose this fraction to these two fractions and start adding them, right? Okay, so this is how we decompose case 1. Also, we can check our solution by adding these, right? So you can check your answer by multiplying to have a common denominator, then simplify and add them, multiply and add them, then you should get the left side. Okay. So let's look at second case. In second case, what we have is we have repeated linear factor. Okay. So first, again, always the first step is factor. So me factor negative 3x plus square plus 13x minus 12. Let's factor x first in the denominator. So we get x squared minus 4x plus 4. Equals we have x times x minus 2 square, because this is perfect square, x minus 2 square. Right. Now when we have non-repeated, or excuse me, a repeated linear factor, we have 3 fractions. So we can have, so let's just write 3 fractions first. And yeah, we can just pick letter A, B, C. Now what goes in the denominator? First we'll have just x, and we'll just have factor of this x minus 2 and x minus 2 square. Okay. So why these 3 is because each of these 3 is a factor of this product right here. Okay. So you must remember that when we have a repeated root like this, we have 3 separate equations, 3 separate fractions. Okay. Well, so I guess I already did the part A, step A, right? But let me write it here again. A over x plus b over x squared plus c over x minus square. Whoops. X minus 2, not x to the 2 power x minus 2. Okay, so now we're going to multiply both sides by least common denominator. So let me write the equations from step 1. So a over x, I'm going to leave some room because I'm going to multiply. So what are we multiplying? We're multiplying least common denominator, which is this. So I'm going to multiply this both sides. So if I multiply it to the right side, I end up distributing this to each of this term. So we can multiply one at a time like this. times x minus 2 square, x times x minus square. So as you can see, the left side cancels out here. So let me write down the multiplied part in step 4. So I have negative 3x squared plus 13x minus 12 equals, now on this one, x cancels out, so I have a x minus 2 squared plus here x minus 2 and one of the x minus 2 cancels out. So I have left with bx x minus 2 plus, and then this one, x minus 2 square, x minus 2 square cancels out, so I just have cx left out. Okay, so once we come this far, what we have to do is just, again, multiply out. So left side stays the same. Here we have a times x squared minus 4x plus 4 plus bx squared minus 2bx plus cx. So let's distribute the a here. Then I get ax squared minus 4ax plus 4a plus bx squared minus 2bx plus cx. So we need to regroup, okay? So let's do this with different color. So negative 3x squared. So which term is x squared? So we have ax squared and bx squared. So let me rewrite in order just to avoid any confusion. Like this. Okay. So then 13x. So which term has x? This one right here. And this one and this one. So negative 4ax minus 2bx plus cx. Okay. Should give us 13x. Lastly, negative 12. Only one left is 4a. So 4a should give us negative 12. So it's helpful to rewrite in terms of collect-like terms. So as you notice, this is x squared term, this is x term, this is just coefficient, just number term. Now let's set this up. Okay, so this tells us that the red part, ax squared plus bx squared, tells us that a plus b must give us negative 3 according to this, right? And the green part tells us that negative 4a minus 2b plus c must give us 13. And lastly, purple part, 4a must give us negative 12. Okay. So write all these three equations. So then we'll notice that here, this tells us that what a is. A is negative 3 if I divide by 4 both sides, right? So a is 3. We found a. Once we found a, we can actually find b from first equation. So negative 3, let me write different color actually. A is negative 3, so negative 3 plus b equals negative 3. So b is in fact 0 in this equation. So now we know what a and b are, so we can find c on our second equation. So we found a, what found b is, so negative 4 times negative 3. b is 0, so this becomes 0. Plus c equals 13. So 12 plus c equals 13. c equals 1. So we found ABC. Okay, so our final answer expressed in, let me write it here, partial fraction decomposition. So let's write the three fractions first. This is how we ordered it. So this is from right here, step 2. And we found what A, B, C are, right? So A was negative 3, B is 0, C is 1. Okay. So in fact, this part was just 0, so our final answer is negative 3x plus 1 over x minus 2 squared. So this is our final answer. And again, you can check your answer by, if you have a multiply common denominator and simplify, you should get the left side. Okay. And you've noticed for this case too, we didn't have to use systems of linear equation, right? You kind of worked that out because he gave us one number, then we can find the second number, then the last number. Whereas in case 1, we had to use 2 equation, 2 unknown variable, so we had to use systems of linear equation solving method. Okay. So again, this is one of those problems that you have to practice a lot. So make sure you know how to do these problems and step by step that I went over. And look at the homework. And please come to office hours, okay, if you want to practice with me.